Okay, got a new sort of problem up here. You'll see a few of these in the homework. I've got a graph here, and I've labeled it as the graph of f prime of x. And I'm going to try to use that to get a graph of f of x. So I'm going to try to sketch an antiderivative for this. And I'm going to give myself an initial condition. I'm going to suppose that at -2, the tick marks here are meant to be 1 unit. So let's just suppose that we're starting here. So I know that my value at -2 is equal to 0. But I want to have that shape for the derivative. So I want to try to graph this thing. Well, I think what I'm going to do is I'm going to borrow a little bit from what we did when we were trying to graph things given a formula for our function. And there we recorded a lot of interesting information about f prime and f double prime just on a number line. Okay. So for f prime, we were concerned about where are our critical points, which would be where the derivative is either 0 or undefined. Well, over this interval from -2 to 2, it's always defined, but I can see it's 0 at 2 places. It's 0 here, and it's 0 here at, looks like -1. So this would be -2, this would be +2. Those are just the endpoints. In the middle here, I've got this critical point. And I can see that my derivative is positive between -2 and -1. Because this is a picture of the derivative. So I'm not looking at what it's doing right now. I'm looking at where it is. Between -2 and -1, f prime is positive because the graph of it is above the x-axis. On the other hand, between -1 and 2, the graph of f prime is below the x-axis. That makes it negative. So I know that my function f is going to be going up, and then it's going to be going down, so that I'm going to have a maximum value when x is equal to -1. Okay. Now, let's see if we can figure out some information about f double prime. So f double prime would be the derivative of f prime. So now I'm looking at, here's my f prime, what is it doing? Well, it looks like it's initially going down, and it looks like it goes down until about there. So somewhere at, so this is -2, and this is 2, little to the left of 1. Until then, my first derivative is going down, so its derivative, which is f double prime, is going to be negative. After that, my first derivative is going up, so its derivative, which is f double prime, will be positive, and that tells me that my graph is going to be concave down and then concave up. So I'm going to start here. I'm going to go up, being concave down until I hit a max when x is -1. Then I'm going to go down, and I'm going to continue to be concave down until I hit this point. It looks like about when x is 3/4, something like that. I'll just put my tick marks here. Okay. Then I'm going to have a point of inflection. I'm going to switch to being concave up, but still going down. Okay. So let's try that. I've got to hit a maximum when x is -1. So I'm going up, and I'm concave down, hitting a maximum at this point. Now I'm going to start going down, but I'm going to stay concave down until I hit right about here, at which point the concavity is going to change. So I'm going to continue going down, but I'm going to switch to being concave up. So my graph will look a little bit like that. Okay. Now, this probably isn't perfect. I just did a very rough sketch capturing this information. Eventually, as we learn more about this process, we'd be able to do a better estimate of how high up is that point. For right now, I just wanted to capture the information about are we going up or down, and are we concave up or concave down, and we've done that with this. Okay. Let's try another one. I'm going to give us a function f prime. Again, my tick marks are 1 unit apart. And let's say we've got something like so. So I'm going to give us a step function here for the derivative, okay? And I'm going to tell us this is f prime of x. And I want to sketch f of x, okay? And I'm going to give us two pieces of information. First of all, I'm going to tell us that our starting point this time is going to be at, well, let's make it the same. Let's make it f of -2 is equal to 0. But I'm also going to tell us that f is continuous. That's important because I can't tell that from f prime because f prime is not continuous. And what I can tell is that f, even though it's continuous, is not going to be differentiable at -1 and at 0. So I'm going to have a sudden change in things there. Okay. So let's see if we can't figure this out. So in this case, I don't think I really need my number lines the way we did for the last example, because here my derivative is constant on each of these intervals. So between -2 and -1, my derivative is constant at 1. So I'm just going to have a line of slope 1. If I'm starting here and I go with a slope of 1, that's going to take me, I know exactly where I go to. I go to this point, -1, 1. Now at that point, there's going to be a sudden change in the behavior, but I'm going to keep going from this point. I'm not going to jump to a different location. Now my derivative is going to be 0 between -1 and 0. So that just means I've got a horizontal line of slope 0, so I'm going to stay at that height of 1. And then at 0, I'm going to have another sudden change in behavior, but since f is continuous, because I was told it was, I'm going to just pick up from this point right here. And now my derivative is going to be -1, and that's over the interval from 0 to 1. So I'm going to have a line of slope -1. Kind of cool. That's exactly right, because I didn't have to do any estimate because I had constant derivatives, so I had constant slopes, and I was told where to start. So that determined exactly what the shape of the graph was going to be.